Welcome to this video where we will take a look at grades 4, 5, and 6 for the State Ed Computer Science and Digital Fluency Standards around computational thinking. At the bottom of your screen is a link that will take you out to the State Ed website where you will be able to find the resources and all of the standards. In computational thinking, there are 4 sub-concept areas. Now, this is the largest of the different concept areas that we will be covering in this series of videos. So we've done impacts of computing. This is computational thinking. There are 4 sub-concept areas that are broken down over 10 different standards. These standards, or these sub-concept areas rather, are modeling and simulation, where we're looking at how we can use models to simulate real world information, how we can look at data and understand or make predictions about that data. The second concept or sub-concept area is data analysis and visualization, where we're thinking about how we can organize that data in a variety of ways in order to communicate the information that we're looking to communicate. The next sub-concept area is abstraction and decomposition. Now, these are big words, but they're things that we do quite often already in our classrooms. So if you look at abstraction as just reducing the complexity of something and decomposition as breaking something down, we know that this is something that is cross-curricular that we can really apply to any of our content. And then finally, we have algorithms and programming. Algorithms truly are just a sequence of steps. So, when you're thinking about tying your shoes or writing an essay or completing a math problem, you are thinking about algorithms. So computational thinking is naturally in our classes, in all that we do. And then programming is really thinking about how we can use those algorithms to make something happen on a computer. So we are going to take a look at some examples. You have 3 links on your page. The first is going to bring you out to the state ed examples to see what the standards are in action according to educators across New York State. In the center, you have the Wakelet collections. That's going to give you more resources, subject-specific resources, and other information. And then finally, you have the activity books, which is where we're going to go today for grades 4 through 6. When we go over to the grades 4 through 6 book within Book Creator, we're going to take a look on the first page, and we're going to click on computational thinking. When we click on computational thinking, it'll take you out to the page in the book that has the concept area of computational thinking, the 4 sub-concept areas. There's a video that can teach you a little bit about what computational thinking is. And then we're going to see the standards for these activity books. The first sub-concept area is modeling and simulation. We have the standard grade band 4 through 6, CT1, develop a computational model of a system that shows changes in output when there are changes in inputs. So the clarifying statement is the emphasis is on understanding at a conceptual level that models or simulations can be created to respond to deliberate changes in inputs. So you're going to take a look at the examples at the bottom here as well. You can see that we've mentioned science on a couple of the examples. We could talk about making recipes, or even in our PE classes, talk about using different types of heart monitors or wearables. Some other resources are here for you to try out, some activities that you can do with your students. And then we get to the next sub-concept area, which is data analysis and visualization. Here we're looking at collecting data related to real-life question or need, and we're really emphasizing that you're using digital tools to collect and organize data points. So this could be done through polls and surveys, thinking about different items that they use within the classroom. The scientific inquiry model can work very well with this. You'll see some more resources, and then we'll continue on with data analysis and visualization. Here we're looking to visualize a simple data set in order to highlight relationships and persuade an audience. So here the clarifying statement is really thinking about how we're going to take that data and really emphasize particular parts of that data to support a claim that we have. So this can definitely be done in math, it can be done in science, it can be done in ELA. It really can be done across anywhere that you would collect data. Continuing on, we're going to move to abstraction and decomposition. Here we're talking about decomposing a problem into smaller named tasks, some of which can themselves be decomposed even smaller. So really we're taking a large problem and breaking it down so it can be more manageable. Again, you can look at the examples at the bottom where we're talking about planning a party or building something, or even thinking about how we write our name with the least amount of pen strokes. So this could be really fun activities that you could do with your students in the class. Moving on with abstraction and decomposition, we can identify and name a task with a problem that gets performed multiple times while solving the problem, but with slightly different concrete details over time. So here we're realizing that you can do the same thing, that there may be some repetition, that we can narrow the focus down. This can definitely be done in math when you're thinking about columns within a data set. And then continuing on with algorithms and programming, you can move on to compare two or more algorithms and discuss the advantages and disadvantages of each specific task. So we're thinking about, these could be unplugged or related to a computer, where we're thinking about how we can get a certain result. So it could be like an origami type of activity, writing down the steps to a math problem, practice doing some sort of drawing activity. It can be done, just to understand that there's parts that help us get to that whole. Continuing on with abstraction and decomposition, we're identifying pieces of information that might change as a program or process runs. Here we're thinking about what needs to be updated. So you might explore history and think about how different things have happened. You can think about how different programs that we use work. You could talk a little bit about code here. You can go a little bit more into the computer science realm and think about doing some coding activities. Continuing on with algorithms and programming, you're going to develop algorithms or programs that use repetition and conditionals for creative expression or solving a problem. So here we're really thinking about those loops, those things you're going to repeat over and over again in order to solve a problem. So this could be going through a maze, or understanding conditionals when you're thinking about math. It could be doing high-end type of computer science, like using Boolean expressions to help you out. We're almost to the end. We have two more in algorithms and programming. 9 is explain each step of an algorithm or program. That includes repetition and conditionals for the purpose of debugging. Here we can think about the steps or tracing through the program as if you were a computer to reveal errors. Here you can talk about the characters or the sprites within a computer program and how they change. It could be some of the debugging that needs to happen. I used to have my students debug their essays instead of editing their essays because they need to make sure that the reader can understand what they're asking it to do or say. You can see some different examples here that can work. And then finally, we get to our last one in algorithms and programming, where we're going to describe the steps taken and choices made to design and develop a solution using an iterative design process. So this is really your perseverance here. We want to make sure that we're trying different things out. We're using the engineering process or the inquiry process, the problem-based learning process in order to solve a problem. And you can see some more resources in here for that. So that is computational thinking for grades 4 through 6. Note that it does have the same standards for 3 grade levels that may span more than one building. And you want to make sure that you're covering these standards as often as you can as you go through those 3 grades.